Hi everyone, let's take a look at the following question. Page 541, question number 8. Part A, determine the coordinates of the point on the line r equal to 1, negative 1, 2 plus s times 1, 3, negative 1, where s is an element of real numbers. That produces the shortest distance between the line and a point with coordinates 2, 1, 3. Step 1. Draw a diagram. If you think about this line relative to the point, again, this point is given as 2, 1, 3. Since you're looking for the shortest distance, this means it has to be 90 degrees. So if I connect this like that, roughly speaking, that's going to be 90 degrees. There's the point, and again, we know this because it's the shortest distance. Shortest distance must be 90 degrees. Now, if I go back to the given, r equals to 1, negative 1, 2, plus the direction vector, 1, 3, negative 1. Now, anytime you have two vectors that are 90 degrees apart, think about the dot product. So again, if I write this on the side, just to give you a refresher, anytime we have two vectors that are 90 degrees apart, so let's say vectors A and B, and they're 90 degrees apart, or you can say pi divided by 2 in radians, this means that the dot product must be 0. So this means we're going to form the two vectors, and again, find the dot product. Now notice this second vector. If I want to find this vector right here, what I have to do is the following. This point is going to be x, y, z. This means the vector is going to be, again, think about vector AB, that's going to be OB minus OA. So in this case, this vector is going to be 2 minus x, 1 minus y, 3 minus z. And you have to dot this to the direction vector 1, 3, negative 1. And again, if I erase this, this means the dot product must be 0. Now, if you go back to the given, you can express this in parametric form. So again, in parametric form, this means x, y, z equals to, instead of writing down the point 1, negative 1, 2, I can write this in a column, 1, negative 1, 2. This is going to be 1 times s. That's going to be 3 times s. And that's going to be negative 1s. And I'm going to plug all this back in. So if you think about x, it's going to go right there. Likewise, if you think about y, it's going to go there. Think about z, it's going to go there. So what that means is, instead of writing down 2 minus x, it's going to be 2 minus in brackets 1 plus s. Instead of 1 minus y, it's going to be 1 minus in brackets negative 1 plus 3s. Instead of 3 minus z, it's going to be 3 minus in brackets 2 minus s. Dot it into 1, 3, negative 1. Now, if you clean this up, this means 2 minus 1 minus s, 1 plus 1 minus 3s, 3 minus 2 plus s, dot it into 1, 3, negative 1, which equals to 0. And if you collect like terms, this equals to 1 minus s, 2 minus 3s, 1 plus s, dot it into 1, 3, negative 1, which equals to 0. On the left-hand side, if you take 1 minus s times 1, that's going to be 1 minus s. 2 minus 3s times 3, that's going to be 6 minus 9 times s. 1 plus s times negative 1, it's going to be minus 1 minus s. Again, that equals to 0. You're going to collect like terms. Now, again, let's make sure no one's left behind here. If you think about negative s minus 9s minus s, that's negative 11s, which I'm going to bring to the right. That's positive 11s. 1 plus 6 minus 1 is going to be 6. The opposite of multiplying by 11 is to divide by 11. So s equals to 6 divided by 11. Now remember, your goal is to find a point. So therefore, you go back to the parametric equations and we're going to solve for x, y, z. So let's draw an arrow back to here. So this means, again, if I plug it back in, x equals to 1 plus 6 divided by 11. Again, you can take your calculator. I'm going to do some mental math. 1 is the same as 11 over 11 plus 6 divided by 11. That's going to be 17 divided by 11. Likewise, if I look at the second case, negative 1 plus 3s becomes negative 1 times, or negative 1 plus 3 times 6 divided by 11. That's going to be negative 1, which is the same as negative 11 over 11 plus 18 over 11. That's going to be 7 over 11. Last but not least, if I think about z, that's going to be 2 minus s, which is 2 minus 6 divided by 11, or 22 divided by 11 minus 6 divided by 11. That's going to be 16 over 11. This implies that the point xyz equals to, in exact form, 17 over 11, 7 over 11, 16 over 11. Now, one more part B. What is the distance between the given point and the line? So at this moment, I would like you to press pause, try part B. When you're done and you press play again, I'll be here. Welcome back, everybody. Here's the answer for part B. Now, if you want to find a distance, basically you have 2 points now, and you want to find a distance D. We found xyz to be 17 over 11, 7 over 11, 16 over 11. If I look at this other point, that was given to be 2, 1, and 3. So when we go back to grade 10 academic math, which we have learned how to find a distance between 2 points in 2-dimensional space, and we're extending this idea in 3-dimensional space. So in general, again, just in case if you forgot, you basically take the following. So I'm going to draw another diagram on the side for you, just to remind you. Again, if there's a point right here, and let's call this x1, x2, x3, and there's a second point here, y1, y2, y3, this equals to D. That is the same as saying, let's go back to the same color here. You take x1 minus y1 squared plus x2 minus y2 squared plus x3 minus y3 squared. So in this context, this means the distance equals to, I can pick the first point, 2, 1, 3 to be there. I'm going to put everything else by copying, minus 17 over 11 in the first bracket, 7 over 11 in the second bracket, 16 over 11 in the third bracket. Now, I am going to express the final answer in exact form and to 1 decimal place. Now, again, I'm going to take my calculator first and work it out. So make sure your calculator with you, turn it on, press clear. Here we go. Open the bracket, 2 minus 17 divided by 11. Close the bracket square, plus open the bracket, 1 minus 7 divided by 11. Close the bracket square, plus open the bracket, 3 minus 16 divided by 11. Close the bracket square. In exact form, that'll be 30 divided by 11 inside the square root. Or if I took the square root, I see the following: 1.6514456648. Or if I round this to one decimal place, it's going to be approximately 1.7 units. Or in exact form, the square root of 30 divided by 11 units. I hope this makes sense.